Here in the next question we have C3H6O, where this C3H6O alkene formula followed by oxygen generally corresponds to a carbonyl compound or unsaturated alcohol. So this may be either a carbonyl compound, otherwise unsaturated alcohol with double bond, and it is treated with KCN in the presence of dilute sulfuric acid. KCN with dilute sulfuric acid is nothing but HCN addition. So if it is a carbonyl compound, hydrogen cyanide is added across the carbonyl group, and then the product formed is subjected to lithium aluminum hydride, and one product P is formed which is optically active. So if we see the options, X is propanol, aldehyde, propanone, ketone, propanol, propanone. So from this we can understand that X is definitely a carbonyl compound. So if X is propanol, so when we take this propanol, CH3, CH2, CHO, when we add KCN in the presence of sulfuric acid, indirectly it is HCN that will be added, which being unstable, it is produced at the reactive site by allowing potassium cyanide to react with the dilute sulfuric acid to give CH3, CH2, CHOH, Cn. And this in the next step is subjected to reduction with lithium aluminum hydride, and we know that in the lithium aluminum hydride this Cn group is reduced to CH2NH2. So therefore CH3, CH2, CHOH, CH2NH2. So this is supposed to be the product P if it is propanol. So thereby if you see this particular carbon, we find one is ethyl group, one is methylamine group, one is hydrogen, one is hydroxy group. So therefore it is asymmetric carbon and expected to be optically active. So therefore X may be propanol, and we are also getting P is optically active. So if A is taken into account, propanol, and P is CH3, CH2, CHOH, CH2NH2. Whatever we got exactly same in A. So A is right option. Then even in C we have X is propanol, but we have here CH3, CH2, COH is given here, and CH3, NH2. So we have one ethyl group, one methyl group. So whereas here we got one ethyl group, there is no methyl group. So therefore C is wrong. Then what about propanone? Why not it can be propanone? If it is propanone, we have here CH3, CH3, and when it is subjected to HCN treatment, then we get CH3, COH, CH3, Cn, and once again with lithium aluminum hydride, what do we get? This will be reduced to CH2NH2. Then what is the difficulty? This is supposed to be the product P. But here if you see, this is methyl group, this is methyl group. So this carbon is not a symmetric carbon. So there is no chiral center. Therefore, it is optically inactive. But what is given? P is optically active. So therefore, X is propanone, right? But this is not the product. So therefore, this is wrong. And X is propanone, and this is the one which is given CONH2, which is not there. So therefore, this is wrong. So A is the right answer.